I asked you, how long will it take to empty this pool, you'd say it wasn't much of a question. A pipe that takes 5 days to empty the swimming pool will empty the pool in, how about 5 days? If I asked you how long it will take pipe 2 to empty the pool, it's just as easy. 7 days. Duh. But as soon as we wonder what might happen if we used both pipes together and ask how many days it will take to do the job, we have a very different kind of situation. It's called a rate of work problem. It looks like it might be hard, but it isn't. In fact, I can show you 3 things that are very easy to do with this problem. First, we can do it wrong very easily. Second, we can estimate the right answer very easily. And third, we can find the right answer very easily. First, a wrong answer? That's very easy. Pipe 1 takes 5 days. Pipe 2 takes 7 days. Both pipes? 12 days? Wrong. We can't add them together because it's going to take less than 7 days and even less than 5 days because we have 2 pipes working instead of 1. Here's another easy way to do it wrong. Average it out and pick the midpoint between 5 and 7. So we say it will take 6 days to do the job. Wrong. Since one of our pipes does it in 5 days, 2 pipes certainly won't take longer than that. The answer will have to be less than 5 days. So how can we get closer to the right answer? If we consider some alternatives, we can estimate the right answer very easily. All we have to do is imagine that both pipes are the same. First we try 2 pipe 1s and then 2 pipe 2s. If they're both like pipe 1, each can do the job in 5 days. So together they do it in half that time, 2.5 days. If they're both like pipe 2, each can do the job in 7 days. So together they can do it in 3.5. But we actually have 2 different pipes, one slow pipe and one fast. So the right answer is going to be more than 2.5 days because pipe 2 is slower than pipe 1, but it's going to be less than 3.5 days because pipe 1 is faster than pipe 2. Our answer then is going to be more than 2.5 and less than 3.5. But don't go thinking it's exactly between the two, namely 3 days. That's just another one of those easy ways to do it wrong. But there's an easy way to do it right. All we have to do is shift our point of view and change the units we're talking about. Instead of days to empty one pool, which emphasizes the pool, let's talk about how many pools we can empty in 1 day, which emphasizes days. Only when we know how much emptying each pipe can do in the same period of time can we figure out how much work they can do together. If pipe 1 drains 1 pool in 5 days, then it must drain 1/5 of the pool each day. What about pipe 2? It drains the pool in 7 days. So in 1 unit of time, 1 day, it drains 1/7 of the pool. Now we have a common measure of the work each pipe can do. We have found the daily rate at which each pipe is draining the pool. With that information, we can combine the work done by both pipes and find our answer.
Okay, from there we have enough information. We have enough information to solve this problem. We're going to set up a table, but this time the table is going to be just one row instead of 2. If one pipe can drain a pool in 5 days and the second pipe can drain a pool in 7 days, how long will it take to drain the pool if both pipes work together? So let's set up our table like this. We already know about rate times time. So now we're going to have, in this problem, a daily rate. Some of your problems will have an hourly rate, but this one's a daily rate times the time. Well, the daily rate of the first pipe we discovered was 1/5. If we multiply that times the time, which is in days, that it's going to work, we'll get how much that pipe will drain of the pool. The second pipe's going to work with it, and its rate is 1/7, and it's going to work the same amount of time. If we add the two together, we will end up with one pool drained. So the combination of the work of each pipe will get one pool drained. Now, this is the part in all of these problems we do. It's a little bit confusing, but it's always going to end up with one job done. If you're writing a paper, you'll end up with one paper done. If you're cleaning your room, you end up with one room clean. Most of these, unless you're cleaning 2 rooms, you're going to end up with one at the end of this equation. So now we can do this easily. 1/5 times t would be t over 5. You can put a 1 under your t if you'd like. Plus 1/7 times t is t over 7 equals 1. This makes it a very simple equation that we've been solving. Let's multiply by the common denominator, which is 35. If you don't want to multiply it together, just leave it 5 times 7. That is 35. We can tell the 5 will cancel, and so we have 7t. In this, that was distributing this to our second term, the 7's cancel, so we end up with 5t equals 1 times 5 times 7 is 35. If we add the 7 and the t, 7t and the 5t together, we get 12t equals 35. Divide by 12 on both sides, and t equals 35 over 12, which a lot of times we like fractions, but that doesn't make much sense to answer how long something takes in a fraction. So let's use our calculator and get 35 divided by 12, and we get 2.92 if we round. 2.92, and that would be days. Now let's remember the question we asked. We asked, how many days will it take to drain the pool if both pipes work together? The answer is 2.92 days.